Well, Joey, in this video we're going to model this 2x1 block with a counterbored hole through it. In models so far, we've positioned the bottom face of our part on the top plane. That doesn't necessarily have to be the case. In this example, we could decide that maybe the counterbored hole is the most important feature in this part. And if that was the case, maybe we would model the part with the base coordinate system at the center of our counterbored hole. So let's do that. So I'm just going to create a sketch, and I'm going to choose the front plane as our sketch plane, and I'm going to draw a circle here on the origin, and the diameter of that circle is 5.6 millimeters. This is actually a counterbored hole, so just for my own reference, I'm going to draw a second circle. So I go back to circle, and I'm going to draw another one there, and that is 4.8 millimeters. And we're not even necessarily going to use these to create the feature, but it just avoid me getting confused. So that's kind of our whole feature through the center of the part. I'm going to create a rectangle by center, hovering over the right plane. I click for the center, and now we've created a rectangle that's based around the base reference plane. And we just want to draw now. So I'm going to dimension the bottom face of our block to the circle is going to be 5.6 millimeters. And the height of the block is going to be 9.6 millimeters. The length of our block is going to be 15.8 millimeters. Oh, and it looks like the relationship that I tried to set up didn't actually work for us, but we can manually create that. So I'm going to create a horizontal vertical relationship. I'm hovering over around the midpoint of this line until the midpoint appears, and now I hover over the actual point and our midpoint glyph appears, so I can just click to select that, and I can go down here and choose the origin, and we have a little bit of an error there. Let's just kind of investigate that now. I'm going to, for starters, just drag to see if we have anything that's stopping this moving. There isn't. Okay, so I'm going to try again. So I'm going to create a horizontal vertical relationship, click on the midpoint of our line, and go down to the origin of our coordinate system and click, and now all of our lines have turned black. It looks like we have successfully constrained our sketch, and that's enough for us to get started. And okay, let's see how we go with that. So I'm going to close that sketch. I'm going to choose finish, and I'm going to choose extrude. And at this time, we're not going to create from coincident plane. We're going to select from sketch, just select the outline of that sketch. I'm going to ignore these two holes here. They were only really drawn for my own understanding. So I tick this little box, and since we want to keep our part symmetrical about the origin where we can, I'm going to choose a symmetric extent, and for the width of our part I type in 7.8 and press enter, and we can give that feature a name, but we don't need to. I'm just going to click finish, and we've automatically gone into the extrude command again. And I suppose we could, while we're here, we could extrude the top two pegs on our block. So let's do that. So we haven't actually created a sketch for those top two pegs. So we're not going to choose select from sketch. Let's choose coincident plane. Click on the top face of our part as our sketch plane. And I'm going to create a circle hovering over I think it's the front plane of our part, hovering over that while it's highlighted. And I just click for the center of our circle. And I'm going to give that dimensions now. So from the edge of our part, we'll position that at 3.9 millimeters, press enter, and the diameter of it, I'm going to say 4.8 millimeters. Now our sketch is fully constrained, so I can accept that. And now we just need to tell Solid Edge how to extrude it. We have an automatic extrude operation, and we've stayed in symmetric, so it detected a volume underneath the sketch plane, so it's automatically gone into the cut, but we can just choose add. We really don't need symmetric extent, so let's go with one-sided extent. And for the direction, I'm going to move my cursor above our sketch plane and type in a distance of 1.6 and press enter. Our prompt bar is saying click the side for the feature. So I'm just going to move the cursor above our sketch plane. So I'm going to click as it is. And I suppose we can call this ParentPeg and press enter. And we've stayed in the extrude command. So maybe let's just take advantage of that. It's more efficient to kind of group these operations together, so we're not going in and out. It's less clicks. So Solid Edge is looking for create from coincident plane, which is right for us because we haven't created a sketch. So I'm going to click on the bottom face of our part, and this time let's go with project to sketch, project with offset, click OK, and we can enter a distance here 1.6 millimeters is here from last time, and that's actually good for us this time. So I'm going to click on the bottom face, click accept, and now it's looking for select the side for the offset. So we have this little orange arrow. If I move below it, it goes outside, it offsets 1.6 millimeters outside the bottom face, inside if I move the other side. So we want it inside, I click while it's there. Now we have a fully constrained sketch. I can tick this box to exit it, and we're still in the add material selection. So I'm going to change to cut, and we're in a one-sided extent, which is fine. And this time let's go with a from to extent. So I click on that. And this time we're going to do things a little bit different. So far we've been choosing the bottom face of our part. But let's look at things a little bit differently. So this time I'm going to choose, before I select the face we're going to extrude from, I'm going to select an offset distance. So I'm going to type in 1.6 millimeters here. And now the from surface, I'm going to choose the top face of our part. And now if we look at the prompt bar, it's saying select the side for the offset. So if I go back down here and look at our part, we have this red arrow previewing we either offset above the top face of our part or below it. I'm going to choose below it. And now looking at the prompt bar, select to surface or right click to extrude to profile plane. So what's the interesting bit here is right click to extrude to profile plane. So instead of going through the process again, I can just right click and that will extrude to the plane we drew our profile on. And that's exactly what we want to do. So it saves us a lot of clicking. Even though the preview, when I'm pointing down, cutting downwards towards our profile plane, it doesn't look pretty. I'm just hoping that the offset of 1.6 millimeters will help us. So I'm just going to have a little bit of faith and I'm going to right click. Oh, we've gone into quick pick because it's looking for a plane. So I'm hovering over planes, which makes life harder. So I'm moving away from where I'm selecting planes and I'm just going to right click. And now let's take a look. For starters, I'm going to hide my planes because they're messing things up a little bit there from the view. Okay, so now let's look. And there we go. That's after cutting right through our part with less clicks, which is always nice. The next thing we can do while we're here is we can start modeling the part around our hole here. So I'm going to do another extrude. So for starters, I'm going to finish the last extrude we did. I'm going to do another extrude from this plane. So I'm going to use a circle and I'm just going to click kind of anywhere on the face for that circle. And I'm going to use create as construction. We don't even need that because everything's modeled around our base reference plane. I could project the sketch we've already made for our hole, but we already know that the center of our hole is our origin. So we can just skip that step and just make this coincident. So I hover over the side of our circle until the center mark appears, click on the center mark, then go to, you can see our reference planes here and our origin here. So click on the origin and now we've made the circle concentric with the origin. And I'm going to make that diameter 6.4 millimeters and press enter and click OK. So all I'm going to do with that now is I'm just going to exit the sketch and I'm going to choose extrude add and I'm going to say again, let's do that. Let's play with this again. Extrude from to extent. This time I'm going to set the offset at 0. The from surface I'm going to choose as this face here. And then for the to surface, remember right click to extrude to profile plane. So I'm just going to right click and boom, there's our circle extruded all the way to our profile plane. That's nice. So we can click finish and let's create another circle, another peg from the bottom. So create from coincident plane, I click on the bottom face of our part. Again, because our part is symmetrical about the origin, we can use that as our center mark. So I'm going to choose circle by center point. I'm hovering over the origin of our base coordinate system and I'm clicking and I'm going to create a smart dimension. Ooh, that's the wrong one. So I'm just going to right click to escape and I'm going to click on it again. And now for the diameter, I type in 3.2 and press enter, click OK. So that is OK. And I'm going to click to exit that box. We're going to do a one-sided extent. And this time, let's go with extrude through next. And there we go. That's just going to, if I point down, there's nothing next. It doesn't ever encounter anything. So it's a fail. But if we point up, it extrudes until it hits the next solid object, which is the circle we just created. So I click on that side and click finish. And that looks good. Okay. And now let's have a look at our hole. So we can choose the hole command. We're going to use create from coincident plane. So I just click on the front face of our part and we have hole options here. So maybe let's choose that. Alright, so now we go into this and we've looked at this once before, I think. And there's a simple hole is started by default, but this time we want something a little bit fancier. We want a counterbore hole. And we have all of these standards here that we can use to define our hole. And it's actually very, very useful if you want to make a hole to a specific standard. But in this case, we kind of don't. So I'm just going to choose millimeters. And now I'm going to manually define our hole parameters. So our counterbore diameter, I'm going to type in 5.6. Our counterbore depth, I'm going to type in 0.8. Our hole diameter, I'm going to type in 4.8. And because it's through next, it doesn't really matter. We could also choose hole extent of through all. It doesn't need a depth because it's going to go all the way through the part. So I'm going to click OK. And now we need to position where this hole is going to be. And the same as before, I can hover over our base coordinate system until the origin appears and click for the point. We've already defined our hole, so it doesn't need a diameter or anything like that. That's defined within our options. So I can just tick on this box to exit the hole command and we can see our counterbore hole there. And I click finish and cancel. Let's look at pattern in this peg. So we've done this a lot of times before. I use the pattern command, rectangular by sketch. That's all fine. And our prompt bar is saying click on a feature. So I just click on this peg, click this box to finish selection. And we're using a sketch now to define our pattern. So create from coincident plane. I click on our top face here and it's looking for the number of parameters. So we want 2 in the X, 1 in the Y. And our prompt bar is saying click for the first point. So I'm going to choose the center of our peg and draw across and click. We could say that our pattern is always going to be 3.9 millimeters from either end, or we could always say that it's going to be 8 millimeters between pegs. Both ways are correct, but making it 3.9 millimeters from each end kind of gives a little bit more flexibility if we decide to edit this part to make a longer block. 3.9 millimeters either end will scale up better than having an 8 millimeter dimension between the first two pegs. And again, the width of our block here, because we're only doing this for one peg wide blocks, our width is less important. I'm going to type in 3.9, but that's not something we expect to have a peg on this corner of the block or along this line of the block at all. So I'm going to close this sketch and click finish. And there's our two pegs. And I was thinking to use a thin wall feature to make our hollow pegs, but I've actually realized that it's probably not as easy as I thought, because we want the thin wall to end at the top face of our part. If I was doing it, I probably should have done it before our pattern. So we can go to hole and choose the go to command. So we're just making any changes before our peg is patterned. We could thin wall this. That would be like splitting the part and making a thin wall between the top and the bottom faces, similar to what we did in the previous video. But maybe let's do things a little bit different in this video, just so we're not repeating ourselves and we're learning different techniques. So maybe for this one, maybe we'll go with edit profile for the actual peg. And let's click on a circle, give that circle a diameter. I'm going to say 3.2 and press enter. Make those two circles concentric and click close sketch and click finish. So now we have a hollow peg and the bottom of the peg is the same plane as the top face of our part. So that's probably more efficient than the other way, but it's nice to see all these different techniques. And now we're just going to go to our pattern, and now it's been patterned as a hollow peg, which is nice. And I suppose the only other thing for us to do now is to maybe try and get this counterbore feature on this side of the part. We could split the part and mirror the part so that we get the feature, or we could also maybe just try mirroring the feature. So I'm going to choose the mirror copy feature command, and we're into the select feature step. I'm going to click on this counterbore hole, tick the box to exit feature selection, and now it's asking for a plane. So I'm going to choose it's not the right plane, it's the front plane. I'll click on the front plane, click finish, and let's take a look. Yeah, So our feature is copied around, so we have a counterbored hole on both sides of the part. Let's actually give this one a little bit of colour before we finish up. So I'm going to say panes, style palette, and select body, replace styles. Looks good. So I'm going to hide the base plane, close the style palette. Maybe we'll just give it a front plane, PMI, section by plane. Tick this box and click finish. I hope you found that helpful. If you did, don't like, don't subscribe. Maybe just write in a little comment to let me know that you're a human. If you can't think of what to write, maybe just write, well, Joey, just so I know you were listening. Thanks. In our next video, we're going to be modelling this Technic peg. Thanks.